Hello there, creatives. Welcome to the fourth lesson on functions. Right, so we are still dealing with inverse functions, but the focus of today is exponential functions, or the inverse of exponential functions. Right, so let me just quickly get on with it. Okay, so now we have already seen the flow in terms of how inverse functions work. Right, so obviously we have seen that your x values for the inverse function will now be the y values of the original function, vice versa, right? Okay, so now let us see. We have this function here. We are given f at x is equals to 2 to the power x, or 2 exponent x. Okay, so when you plug this x values into the function here, you'd get that, okay, the y value here is equals to 1 over 2. So negative 1 is to 1 over 2 would be somewhere here. Negative 1 over 2. Let's put it right there. Then 0 is to 1. 0 is to 1 will be somewhere there. Then 1 is to 2 will be somewhere there. Right, so this is 1 is to 2, right? So you can see that this graph here takes this shape here. Okay, so that is the shape of the exponential function there. Okay, right. So, as we know that this graph, or the exponential function, is a reflection of the inverse, or the inverse is a reflection of the original exponential function. So we know that we always have an axis of symmetry here. I see I did not include that in the others, but we'll always have an axis of symmetry here. This is the line x is equals to y. So you know that the inverse, right, is the reflection of the original graph at the line x is equals to y. So you can also do that with the other functions, like your straight line functions, your quadratic functions, right? Okay, so now let us see here, what are the points that we have? So this is the point negative 1 is to 1 over 2. This is the point here 0 is to 1. Right, so this is the point 0 is to 1. Then this is the point 1 is to 2 here. Right, so 1 is to 2. Okay. Right, then now what about the inverse? What would be the inverse? So remember, the rule in terms of inverses is that, okay, still would have the same values here. So that will be negative 1, 0, 1, 1 over 2, 1, and 2. The difference now is that the y values here will now be the x values, and the x values will now be the y values. Okay, so now we can put that into the Cartesian plane. Right, we can draw that using a different color. So here we have 1 over 2 is to y, then 1 over 2 is to y would be somewhere there. 1 over 2 is to 1, to negative 1, sorry, then we can put it somewhere there. Then 1 is to 0, 1 is to 0, that will be 1 is to 0, so that will be somewhere there. Then the last one would be 2 is to 1, which we can find there. Right, so if we can draw the graph here, you can see that it's taking this shape here. Please bear with me, my shapes here. Okay, so now this is the function here. So you can see that this is just the opposite, right? So now here we'd have 1 over 2 is to negative 1. So on this one here, you'd have 1 is to 0. And on that last point there, you'd have 2 is to 1, right? So basically, that's how an inverse is formed, right? So how would you find the equation? So we still apply the same rule that we've been applying on the previous functions. So we have the original function here being f at x is equals to 2x. So the first thing is to change this into y is equals to 2 to the power x. Then what next? You now interchange. So what was y becomes x, and what was x becomes y. So that is equals to 2 to the power y. Then now, how do you make y to be the subject of the formula? Now that's where the logs come in handy, right? So we use the rule for exponents that says now exponents, or the exponent, is equals to log, then base, then number, right? Okay, so here, what is the exponent in this case? It's y is equals to, then log, what is the base? The base is 2. So that will be 2. What is the number? That will be x. So now that will be the formula for the inverse function. So now we can represent it using this here. The inverse will be equals to log 2x. So you see now that, okay, an exponential function will produce a log function, meaning the inverse of a log function will also be the exponential function. So that's how we play around these two graphs. Okay, so now I want us to look at the types of logarithmic functions that we have, right? So we actually have two types of logarithmic functions, right? Okay, so the first one is where the base is between 0 and 1. So, right, how do we see the difference there and how does that help us? Okay, so let us check that. Okay, let us check that. Let me just take this thing off here. Right, so please make sure that you are following and you're not getting left behind. Right, so we are done with the inverse. That was very quick now. So we're now good with inverses here. So now let us distinguish between the two types of logarithmic function. So the first one, it's where the base, is between 0 and 1. So you find that the base is between 0 and 1. Okay. All right. So when the base is between 0 and 1, what are we expecting of this function? We're expecting it to be a decreasing function, right? So this is just extra nodes, right? So we're expecting this to be a decreasing function. So how do we see a decreasing function? So we have our Cartesian plane there, and I won't be using a ruler because I just want to explain the concept. Right, so a decreasing function, we know we start reading the graph from the left hand side. So we're coming this side. So a decreasing function would be something like this here, right? So this is a decreasing function, right? Okay, so this is a log graph where b is between 0 and 1. So this is a decreasing function, right? Then the second type of function, it's where the base is greater than 1. So the second type of function is where b is greater than 1, right? So when the base is greater than 1, we are expecting an increasing function. So remember, we are starting to read the graph from the left hand side. So an increasing function would be something like this there. Right, okay. So now this is the graph where the base will be greater than 1. So this is an increasing function, right? So I hope that this, guys, makes sense and you guys now understand how inverse functions work. So if you grasp all this content that we have been doing here, then there's no way you're going to be struggling with any question that deals with inverse functions, right? So what you just need to know then, distinguish, is that your x values will become your y values on the other graph, and your domain will become the range of the other graph. So you know all those questions that they usually ask, the range, the domain, and everything. So you just see that I'm going to be swapping there. That's the only thing I'm going to be doing. So I'm just hoping that I'll be able to do questions so that you guys, exam type of questions, so that you guys follow as to how the standard of setting in inverse functions is, right? So other than that, thank you guys. This is the end of our lesson. Please make sure that you do subscribe to our YouTube channel and follow us on TikTok and all our social media platforms, right? I hope that this was useful to you, and continue to share these videos with others as well. Thank you.